Good morning, and this is the first concept being reviewed for the final exam fall 2022. And this concept, you will be able to work out the problem, any problem in fact, connected to this concept. So here is the question. Two masses are connected by a string which goes over an ideal pulley as shown in the figure. Block A has a mass of 3.00 kilogram and can slide along a rough plane inclined at 30 degrees to the horizontal. The coefficient of static friction between block A and the plane is 0.400. What mass should block B have in order to start block A sliding up the ramp? So we're trying to find out the minimum mass of B so that block A begins to move. So in fact, block A and B both together begin to move. That is why the coefficient of static friction is given. Now, static friction is the friction that opposes the motion of an object just before the motion begins. On the other hand, kinetic friction is after the motion begins, so while it's moving. So in this case, we have to draw the free body diagram. We have to look at the forces acting on each object individually. So that's what we're going to do. So let us look at the forces on object A. First, the weight of the object acts vertically down. That's always the case. The weight of any object due to the gravitational force always acts vertically down. Second, the frictional force is always opposite to the intended motion. Now, since object A is trying to move up the ramp, friction is going to be down the ramp, and it's always going to be tangential to the two surfaces. Or in other words, it's along the ramp, parallel to the ramp, but in the opposite direction. The next force is the normal force. This is the perpendicular force acting to the surface, which is because of the object pressing down on the surface, which creates this reaction. That's the normal reaction. And then we have the tension in the string, which is responsible for moving it up. So those are the forces that act on object A. And in this case, we fix our X and Y axis with the X-axis along the ramp and the Y-axis perpendicular to it. Because of that, we'll see that three of the forces are either along the ramp, these two are along the ramp, which will be along the X-axis, and this force is along the Y-axis, perpendicular to the ramp. So we need not do anything to these forces. They are either along the X or the Y-axis. But the weight is neither along the X nor the Y-axis. Therefore, we need to resolve it, or in other words, break it into its components. That's what we're going to do. When we break up the weight into its components, you're going to get mg sine theta and mg cosine theta. So here are the symbols for the forces. mg is the weight, and now you can see that mg is broken up into its components. This is mg cosine theta. Why? Because this angle is theta. That angle would be exactly this angle. Same thing if you draw this diagram here. Therefore, that becomes the adjacent side. This is the opposite side, which you could draw here. So Now, what's the net force along the x-axis? We have three forces along the x-axis. T is the tension, which is to the right. The other two forces, friction and mg sine theta, are to the left. So the net force is T minus F minus mg sine theta. But according to Newton's second law, the net force is equal to mass times acceleration. So the net force here is equal to the mass of the object times the acceleration. So that's the application of Newton's second law in this case. But we know that friction, static friction in this case, is mu times n, where mu, or mu sub s, is the coefficient of static friction. And n, if you look carefully, n is exactly equal to mg cosine theta. That is because the object is not moving along the y-axis, so these two forces have to cancel out. That's why n is equal to mg cosine theta. So you substitute for n as mg cosine theta, and now that we got the formula for friction, we will plug it back into this equation. So T minus, in place of friction, you have mu mg cosine theta from here, minus mg sine theta is equal to m times a. So that's what is coming up. Okay? So mu is given as 0.4 g. We got the mass as 3 kilogram. That's the mass of block A. G is 9.8 times cosine of the angle. The angle is 30 degrees. So that's the second term, mu mg cosine theta, mu mg cosine theta, minus mg, again, 3 times 9.8 times sine of 30, is equal to the mass of the object. Remember, we are only focusing on object A. We do not care about object B at this point. That's why it's called a free body diagram. And so the mass is 3. We're looking at the mass of A times the acceleration. So if you look at this, the only unknown quantity, no, there are two unknown quantities actually. We do not know the tension, we do not know the acceleration. So when you do this, take the product of all of this, you get 10.18. When you take the product of all of these, you get 14.7. That's 3 times A. And then you can combine these two negatives to give T minus 24.88 is equal to 3 times A. So that's one of our equations with two unknown quantities. And how did we get that? We got that from applying the free body diagram to object A. Now let's look at object B. What are the forces acting on object B? There are only two forces on object B, and one of them is the tension in the string upwards, and the other is the weight. And weight is what? mg, so we do not know the mass, so that's why we have labeled it as m times g, which you can see here. So T minus mg, so 9.8 m, we do not know the mass again, is equal to minus ma. You got to be careful here because T is up and mg is down. Anything up is positive, anything down is negative, is the idea that we used here. That's why this is minus 9.8 times the mass. And since the acceleration of this object is down, it's moving down, isn't it? That's why A also is negative. That's why you have the negative on the right side. So now that we have our equation number 2, we got to solve the two equations either by elimination or substitution. From this problem, in this particular problem, you cannot apply this to everything, but this question talks about just moving the block A. Therefore, the acceleration is 0. It's just beginning to move. That's why the acceleration is 0. And so once you plug in the value of acceleration is 0, that from equation 1, because this becomes 0, then you know the tension is 24.88, and then plug it back into this. So 24.88 minus 9.8 times the unknown mass becomes equal to 0, from which we are able to calculate the mass of the unknown object. So we will get the answer. And while that is going on, just think about what could be the variations of this problem. The major variation could be if the question talks about the object A already moving. Then instead of static friction, we will be using kinetic friction because it's already moving. And in that case, the acceleration is not 0. So either the acceleration will be given, will not be 0, and you'll have to plug in the value to solve the equations. Or solve the two simultaneous equations to get both the tension and the acceleration. So remember that there could be different variations of this. Another variation is, what if theta is 0? If theta is 0, that means the surface now becomes horizontal. If the surface becomes horizontal, wherever you have theta, you got to see 0 now. And remember, sine 0 is 0, and cosine 0 is 1. So those changes will happen. Now, these are the two major variations that could happen with this question. So when you prepare, try to understand everything completely, because surely there is one problem based on this on the final exam. Hopefully you've understood. Thank you very much.